Hello students, in this lecture I would like to explain you optics. So optics is important for IIT, mains, advanced, NEET and AIMS. So I would like to explain you optics in a simple manner. So I would like to start the introduction to optics. Let us see what is optics. Okay, now see. So optics. What is optics? Simple. Optics is study of nature of light and the propagation and the direction of the propagation of the light. Okay. So optics is classified as mainly three types. Optics is mainly classified as three types. So first one is considered as geometrical optics. Geometrical optics. Or you can call it as ray optics. Ray optics. Geometrical optics, ray optics. So next one is called as physical optics. Physical optics. Or it is also called as wave optics. Wave optics. Right? Next one is quantum optics. Quantum optics. Or it can also called as, it is simply quantum optics which is useful in modern physics. We will use in modern physics like using photoelectric effect or quantum effect. Examples, quantum optics. Let us see in detail what is geometrical optics, what is physical optics. In our syllabus we have geometrical optics and wave optics. So let us see what is when we consider these optics as a geometrical optics or ray optics. See actually ray optics. See we are using in ray optics we are using mirrors, objects as mirrors, maybe we are using mirrors, and lens we are using, prisms we are using, telescopes, etc. All these are considered as objects. Now the dimensions of these objects, dimensions of objects, these objects is greater than the wavelength of light, wavelength of light, then it is considered as geometrical optics. So it is clear the dimensions of the objects like mirrors, lens, prisms and telescopes we are using in geometrical optics. If the dimensions of those objects is greater than wavelength of light, then it is considered as wave optics. So see here, what is the meaning of it? See, generally, if you consider the characteristics of the light, if you consider the characteristics of the light, we have like wavelength, frequency, time period, and so on, amplitude, and so on. So, in this case, because of the dimensions are bigger when compared to this light wavelength, so this wavelength is very neglectable. So, we are not considering any properties of the light. So, that's what we are focusing on, only these dimensions of the object. We are least bothered about the wavelength of that light. That's what we consider light as a simple ray, and group of waves is considered as a beam. So in this case the light we consider as only a rays. Coming to the physical optics. Physical optics, here the wavelength of the dimensions. What are the objects we are using here? Objects are simple. You can use slits or holes. These are the objects. These slits are holes. The dimensions of these slits are holes. Dimensions of objects here are slits are holes is comparable to wavelength of light. Compared to wavelength of light, then it is considered as physical optics or wave optics. So one thing here is simple. Here the dimensions of these objects like mirrors, lens and prisms are greater than that of the wavelength of light. So here the dimensions are dominating, wavelength is neglectable. So that's what we are considering the light as a simple ray. Here we are considering here the dimensions of the objects is comparable to wavelength. That's what we are considering the wavelength of light. So that's what these will come under the physical optics or wave optics. Coming to the quantum optics. In this quantum optics, see if the energy sensitivity of the instrument, energy sensitivity of the instruments are comparable to energy of photon, energy of photon, energy of photon. That is energy sensitivity of the instrument are comparable to the energy of the photon, energy of the photon. Then it is considered as quantum optics. That is we are using in modern physics like photoelectric effect, Crompton effect. Coming to the here in this case, just the dimensions of the objects are comparable to the wavelength of light. Here the dimensions are very much bigger than that of the wavelength of light. So that's what here we consider as the geometrical optics. In this case we have physical optics. In this case we have quantum optics. This is the just classification of optics. Let us go for the next concept. Now, see actually light, behavior of light, behavior of light moves in medium, moves in medium. How it is behavior? This is very well known. Suppose if you consider a medium, so this is the normal, this is the normal, as you know. This is considered as an incident ray which is coming from infinite distance. So this is incident ray, incident ray. Very well known, this is an incident angle, of course. And this is the reflected ray, you know very well, reflected ray. And this angle is considered as reflected angle. The first law of reflection is law of reflection. Law of reflection. In that law of reflection, the first rule is simply the incident ray, normal and reflected ray should be on same plane. Should be on same plane. This is the first rule. See here the incident ray, normal and the reflected ray should be on the same plane, right? The next rule is where the angle of incidence, that is I, the angle of incidence I and the angle of reflection, that is R, should be equal. These are the two rules which are used in the light when it is travel from one medium to another medium or which travels in the same medium. So here simply law of reflection is the first one is incident ray, normal and the reflected ray should be on the same plane. Next one is angle of incidence is equal to angle of reflection, right? That is. So here the important thing is this surface may not be a plane surface. It may be any zigzag surface. In this case, light is allowed to incident on this surface. This is I and this is the normal and this is the reflection ray. So this is I, this is R. In this case also angle of incidence is equal to angle of reflection, but one thing may be it may be having different reflections. So suppose it may not be a plane surface, it should be any curved surface. So there also these rules are satisfied. Next, now the important thing we will discuss in this concept is it is useful for mains as well as advanced and aims. We have to derive the vector form of laws of reflection. That is most important in this lecture. Let us see that. Now, vector form of laws of reflection. Vector form of laws of reflection. So what is this vector form of law of reflection? See, generally, just now we discussed this. This is the surface, and this is the incident ray, and this is the incident ray, and of course this is the reflected ray, and this is the normal. This is the normal. This angle of incidence is equal to angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Now, I would like to derive the, and of course you know angle of incidence is equal to angle of reflection. But I am deriving the vector form of loss of reflection. So, vector form of loss of reflection. So, in this case, now let us consider same thing. Now, this is a surface. This surface, of course, this is a surface. Okay. Now, this is the normal for this surface, and I would like to consider as normal vector, which gives the direction of the normal, and this is the incident light, which is coming from infinite distance. So this is the incident light, and the direction of the incident light is you can consider as I cap. So this I cap is the incident vector, incident light vector, and N cap is the normal vector, and of course this angle you can consider as incident angle, and it would be reflected back. Now this can be considered as incident ray, and R cap is the unit vector for this reflected ray, as you know. And of course, the angle of incidence is equal to angle of reflection, you know very well. Now, here, this is the normal, and this is the reflected vector, and this is the incident ray vector. So, now, in this case, this incident light vector is resolved into two components. See how I am resolving this into two components. See carefully. So if this is theta, this is theta. Now this I can write as I modulus of I. This I can consider as cos theta. Okay. This is what? This is modulus of I bar, and this is sin theta. This is, you know very well this concept. Resolving these incident vector into two components, parallel component and perpendicular component. This is I sin theta and this is I cos theta. Now in this case, as usual, in this case, now these are the corresponding angles. This is theta. Of course, this is theta. Now here is r bar sin theta, right, students? R bar sin theta. This is what? R bar cos theta. R bar cos theta. Now I can write this as I cap is equal to I cap. See carefully. I cap is equal to x component. X component is modulus of I bar sin theta along x axis. Along x axis. I. This is, see, if you consider this, see, this is I, this is j, this is minus I, this is minus j. So this is down, this is what? Minus I bar cos theta j. Minus I bar cos theta j. You know this. Minus I bar cos theta j. Now this one, reflected ray vector, unit vector. So r bar cap is equal to, I can write this one as, this one along x axis, r bar, this one is sin theta or sin theta, this one is I cap, right? That one is plus, this plus j. So plus r bar, that is cos theta j. Right? Read out, simple. Now you can subtract r cap I cap. If you subtract r cap I cap, you know this is a unit vector. So unit vector modulus of I is 1. Similarly for reflected vector is equal to 1. So unit vector, its magnitude is 1. So this is sin theta I minus this is cos theta j minus of this one. I am considering this one. First r bar minus r bar. This is r bar is this is sin theta I plus cos theta j. This one is minus sin theta I minus of minus plus cos theta j plus cos theta j. So what we have here is this minus sin theta, this minus sin plus sin theta get cancelled. So r cap minus I cap is equal to cos theta j cos theta j. What you have 2 cos theta j. This is an important result. Please keep it in mind. Right? Now, if you extend this incident vector in this direction, so this is incident vector. Now the angle between this normal and the incident vector. See the angle between the normal and incident vector. Normal is n cap and incident vector is I cap. You know normal and incident vector a bar dot b bar, that you can write as a bar b bar, that is I cap. And what is the angle between these two? This normal and this total is 180. This total is 180. You can write as pi minus theta. This angle is pi minus theta because this is theta, this is 180. So this is pi minus theta. So this instead of cos theta I can write as cos pi minus theta. I hope you understand this. Now this further n cap normal vector direction, I cap incident light direction is equal to this one is modulus of n, modulus of I. This one is cos 180 minus theta minus cos theta. Of course, these two are 1 because they are unit vectors. So n cap dot I cap is equal to, you have minus cos theta. So there you can substitute here. This is equation 1 and this is equation 2. You can substitute equation 1 in 2. If you substitute equation 1 in 2, see equation 1 in 2, so r cap minus I cap is equal to 2. Instead of cos theta, what you can write as? Minus. Instead of cos theta, what you can write as? Cos theta is equal to, I can write cos theta is equal to minus of n cap dot I cap. Right? N cap dot I cap. So this is minus n cap dot I cap into we have j cap. Now it is clear. So instead of cos theta, minus of, I would like to put bracket inside. Clear. Minus of n cap dot I cap, that minus. Now see this j is in this direction, j cap is this direction, and n cap is also same direction. See, you clearly observe the j cap is upward direction and this one is also upward direction, that is y direction, both are. So I can write as n cap unit vector n cap is equal to, I can write as j cap. So r cap is equal to I cap minus 2 n cap dot I cap. Instead of j I can write as n cap. So final result, reflected ray r cap is equal to I cap minus 2 n cap dot I cap into n cap. So this is the final result